probably the most common type of attack against a web app is an injection attack, where the attacker injects some kind of malicious code or query or something into the front-end form of the web app. So instead of just putting in first name, last name, I'm putting in all sorts of stuff I shouldn't be putting in, and then getting the web app on the server to execute that stuff. So, injection flaws. These are vulnerabilities in web apps that permit untrusted data to be used, to be processed. And this really comes down to just bad coding, okay? Attackers use malicious commands or queries to exploit injection flaws. And injection flaws are common in legacy code, but quite honestly, most developers, quite frankly, don't know how to write in into their code something to validate input to stop injection flaws. Now, here are some common ones. SQL injection, command injection, meaning non-SQL, or LDAP injection, meaning I'm querying an LDAP server like Active Directory. In a SQL injection attack, the database is manipulated by a series of malicious SQL queries, or what we call statements. Normal security measures are bypassed because of the vulnerable web app, and the attacks can be executed in an address bar, in an app field, in a search, or a query. Let me actually describe this. This is sort of a no man's land. SQL injection first became noticeable in 2005, and it was the sort of the underlying thing that drove the SQL Slammer worm, which was a serious virus that just went around the world. It impacts every kind of database that uses the SQL language. And I mean from your phone to Microsoft SQL, MySQL, even Oracle SQL mainframes. And the reason why is because the way I see it, you have two groups, neither of which are really taking responsibility. Now, a lot of folks will say that it is a web app vulnerability. That is only partly true. So you see, I have a web app with a form, and I put in things in the form like my customer number or the product I'm searching for or my order. And the app is going to consume the form and take the input and go query a database and return some kind of result. Well, if the person who writes the web app does not do input validation, I could put all sorts of malicious code, malicious SQL statements, malicious SQL queries into that web app, that form, and the web app will run those malicious queries against the SQL server. So you can say, aha, it is the fault of the web app developer. Well, yes and no, because the person who developed the database should not trust the web app. They should, on their own, have stored procedures and other things that force the web app to only give certain kinds of input. So it's really, SQL injection falls across both of those things. And I frankly don't see either side taking their share of the responsibility. So with a SQL injection, we are indeed manipulating the database by inserting malicious SQL queries into the form of a web app. So we are using normal SQL queries, but in a malicious way. Now, SQL has basic functions: select, insert, delete, update. These are SQL statements. I am not trying to teach you SQL per se. There are whole classes on SQL. Select just simply means return me some results. Read something off of a table and give it to me, like select star, meaning everything from customers. Give me a whole list of all the customers. Insert means to add a record. Delete means to delete a record, like delete somebody's order or delete a customer. Update means to update a record. It's different from insert, because insert you put in a new record, update you update an existing record. So these are the basic SQL functions. You should, when you're a web app developer, be testing every input element, from the URL to the forms to the cookies, whatever, and make sure none of them allow just ad hoc crazy SQL queries where we're asking for all the credit card numbers from the credit card table. The simplest injection method is to use use what we call an escape character, a single apostrophe, a single quote. That in and of itself will help reveal whether or not this whole setup is vulnerable to SQL injection. It might even give you helpful syntax to say how to do it properly. What you do then is, after you put in a single quote into a form just to see how it responds, and you say, aha, this looks pretty vulnerable, now you start putting in like whole SQL queries into that name field or password field or whatever it is. So you add an apostrophe, a single quote, to a username field in a login form. The apostrophe, of course, is not a valid character for a person's name. Well, actually, that's not true. I mean, we have people with apostrophes in their names, but they won't start with an apostrophe, okay? Names won't start with that. So if you just put in an apostrophe, a single quote, that by itself is not a valid name, just the apostrophe. It will trigger an error. And the response could include or could indicate names of different columns and tables. Now I know what to query for. It can also indicate where to add parentheses to complete syntax. So they're trying to be helpful here, not realizing that you're being malicious. You can also leverage what are called always true values and comment characters, we're going to see in a moment. There are certain web APIs that allow you to stack queries in the same call. In other words, have multiple queries in the same activity, the same transaction. SQL has what's called a union operator, which basically takes the full results of two select statements and puts them into a single table. And so we can have like something phony union the credit card table, and we'll get the whole credit card table. Union statements work best when the queries have the same number of columns. It's not that it only works, but it works best that way. You could provide actual column names, or you could just say select everything, select star. So here's a really basic SQL injection example. This is this is an OR statement. You have two elements here separated by OR. Now remember what I said about apostrophe. You put in something, and we don't care what it is, escaped by an apostrophe. This one is not valid, therefore it is false. But this one, 1 equals 1, is always valid, therefore it is true. With an OR statement, we only need one of these to be true. 1 equals 1 is always going to be true. This one we don't care about. Okay, so now you keep this in mind. We could use a select statement. Select meaning give me the account number and the balance from a table called accounts, where the account owner ID equals 0. In other words, the very first account. Or 1 equals 1. The fact that this is true means this will also run. How do you like that? In addition to SQL injection, we can have other kinds of command injection. We could have shell injection, where the attacker gains shell access to a web server by creating an input string. Remember, a shell is any sort of interactive prompt. We could have HTML injection. We add additional HTML-based content to a vulnerable web app to maybe deface the website. We could have file injection, where we put malicious code into system files. So code injection here is enabled by weak or non-existent input processing. It can permit denial of service against the app, privilege escalation, especially exposing and exfiltrating, in other words, leaking out sensitive data, or installing malware on the server, or defacing a website, or. The mechanism, the output, depends on the types of languages that are used in the injection. So you obviously would focus on languages that are supported by web app technology. HTML injection, this is an attack where the different HTML elements are injected into a web app for malicious purpose. What are HTML elements? Well, HTML has things like get and post and other things that come in tags. Like other injections, you are targeting input components. You're adding valid code that the app will execute, but it's for malicious reasons. It's commonly used to modify page content. The web app has a field for submitting feedback. That would be a legitimate use of HTML injection. But the feedback is displayed on a page for others to see, but they don't bother sanitizing the input. So now, instead of like normal feedback about a product, where I'm like saying what I thought about the product that I just bought, I'm putting in all sorts of stuff that I shouldn't be putting in. So that HTML gets added to the page because the app failed to strip out any tags or any special characters. Some poor user browses the page, clicks a link, and it's all over for them. So you combine this with social engineering, and they click something that you posted, like you're doing a review on a product, and now they're in trouble. An LDAP injection is where we are trying to inject something into a search of a directory service. So LDAP, Lightweight Directory Access Protocol, is the search and edit protocol to talk to what we call an X500 compliant directory service. In other words, Active Directory, Microsoft Active Directory. It stores and organizes data in a hierarchical manner, and that data is usually domain and user and computer and group information. It is based on a client-server model. There are any number of LDAP tools that can query an LDAP compliant server. And so clients can then filter and search throughout the whole directory. Now, as I have said somewhere else, a normal Active Directory user has the right to read just about anything. Now, as I have said before, a normal standard Active Directory user has the right to read just about anything in Active Directory, unless it's like a password or something encrypted, or it specifically has permissions on it. And they can use LDAP to search and read that stuff. So in LDAP injections, we get past any filters by taking advantage of non-validated web app input. Once again, in our web app, we are not checking the input to make sure it's legitimate. That allows us to use the web app to start reading all sorts of stuff in Active Directory or any other LDAP compliant database. And we can use whatever input parameters to create whole LDAP queries. So this LDAP vulnerability can be tested by sending a query to the server. So these are some examples of injection attacks against web apps. We will go deeper into SQL injection a little bit down the road.